Good morning. In this video, I'm going to go through mass stoichiometry, which is an important concept for honors and AP chemistry. After watching this video, you should be able to explain the steps of solving a mass stoichiometry problem and apply those steps. The whole concept of stoichiometry builds on the premise of mole ratio. Here I have sodium reacting with chlorine gas to produce sodium chloride. The mole ratio is from the balanced equation. The coefficients here are 2, 1, 2, which means that for 2 moles of sodium, I produce 2 moles of sodium chloride. For 1 mole of chlorine, I produce 2 moles of sodium chloride. In this question, it asks what amount of moles of chlorine gas is needed to react with 100 moles of sodium. So you're given with 100 moles of sodium, it's asking how many moles of chlorine will be needed. And we know the ratio is a 2 to 1 ratio. To solve this problem, I start by writing out 100 moles of sodium. And in the end, I want to have moles of chlorine. So left side is given, right side is unknown. To find the moles of chlorine, I need to do some sort of conversion using the mole ratio. So I need to have moles of sodium in the denominator so that my moles of sodium and moles of sodium can cancel out. And I have moles of chlorine in my numerator, which is what my end product unit should be. So, and this 2 is from the balance coefficient. This 1 is also from the balance coefficient. This step right here is called the mole ratio step. I do 100 times 1 over 2. That gives me 50 moles of chlorine, which suggests that 100 moles of sodium need to react with 50 moles of chlorine. The goal of ideal stoichiometry is that you can predict the mass of substance B for reacting any given mass of substance A in a chemical reaction using a balanced chemical equation. In this example, this reaction is a mixture of two aqueous solutions, resulting in a solid precipitate aluminum hydroxide. Aluminum hydroxide mass can be predicted if you know the concentration or starting quantity of aluminum chloride and sodium hydroxide. So let's start solving a mass stoichiometry problem. We need to take our mole ratio problem a step further. I have the exact same reaction, but here, the only thing different is instead of asking how many moles of chlorine gas, this asks how many grams of chlorine gas. I can start the same way. 5.5, so 5.75, there's a small typo here, moles of sodium. In the end, I want to see how many grams of chlorine gas. So I'm going to start with what's given, 5.75 moles of sodium. And the coefficient for sodium is 2. So I'm going to have 2 moles of sodium to 1 mole of chlorine. So this is a 2 to 1 ratio. Now, what unit do I have now? The moles of sodium and moles of sodium cancel. I have moles of Cl2. But I am asking for how many grams of Cl2. What happens next? I can use molar mass to convert moles of chlorine to grams of chlorine. Those diagonal units cancel out. 71 is the molar mass for Cl2. Therefore, after doing this math, I have 5.75 divided by 2 times 71. That gives you 204 grams of chlorine. The only thing different here is that I multiplied by the molar mass to convert from moles of chlorine to grams of chlorine. So now I started with moles and ended with grams. But that's not enough for a mass stoichiometry problem. But the general step is that you're going to be given with a mass. So we need to first divide by the molar mass of the unknown, multiply by the mole ratio, and multiply by the molar mass of unknown. You start with a known mass. You divide this by the molar mass of the known quantity. You use the mole ratio in the middle step. In the end, you multiply the molar mass of the unknown. The units should cancel out mass, molar grams. The diagonal units should cancel out, which I'll show in the next slide. In the end, your answer is going to be in grams of unknown if that's what the question is asking for. The middle step is the mole ratio step. You read that from the balanced chemical equation. Let's look at this example. How many grams of sodium are required to produce 126 grams of sodium chloride? What is my known quantity here? My known quantity is sodium chloride. What is my unknown here? My unknown is grams of sodium. So sodium and sodium chloride is a 2:2 ratio. What I can do is I start with a known quantity, 126 grams of sodium chloride, divide this by the molar mass so that grams of sodium chloride cancel out. Molar mass by definition is 58.44 grams per 1 mole. Now use the mole ratio so that moles of sodium chloride and moles of sodium chloride cancel. And in the end, I want to be in sodium, so I use moles of sodium, and then I multiply them by the molar mass of sodium. That gets me 49.6. Let's look at a different example. Pause for a moment to see if you can solve this problem. I start with 54 grams of SO2 because that's what's given in the problem, SO2. And it's asking for what's the mass of oxygen. So I divide by the molar mass of SO2 so that diagonal units can cancel out. I multiply by the mole ratio. Note that because I want to end in grams of O2, I should say O2. I want to end in grams of O2. I should have moles of O2 up top and moles of SO2 down to the bottom so that they can cancel out. This 3 and 2 are from the balanced equation, and 64 and 32 are the molar mass of the corresponding chemicals. Let's consider this challenge. In an experiment to determine the reacting ratio of moles between a metal X and bromine gas, it is found that 4 grams of Br2 reacts with 1 gram of X, and that X has a molar mass of 40 grams per mole. Calculate the molar ratio, hence the chemical equation. This is a little more challenging and is about the level of AP exam if they were to ask a challenging stoichiometry problem. So in this problem, you're not just solving for a mass to a mass, but the general approach is the same. You start by writing out the skeleton equation as if you know what X is. You are given with mass of Br2. You know the molar mass of Br2 from the periodic table. You know the mass of X. You know the molar mass of X. The only thing you don't know is the mole ratio. So if I were to set up a calculation like the one before, the only part I don't have is the middle step. So what can I do? Let's start by considering Br as my reactant, X as my product. Mass of Br, divide by the molar mass of Br. I end with the mass of X, and I have the molar mass of X right here. The missing part is my mole ratio. Now I can solve for the ratio here. If I combine all the terms, so 4 divided by 159.8 times 40, that gets me about 1.001 times ratio equals 1. What should ratio be equal to? If I divide both sides by 1, the ratio is 1. So therefore, I can effectively conclude that the ratio between Br2 and X is 1 to 1. So I know that in a balanced chemical equation, Br2 and X are going to be in a 1 to 1 ratio. So this is an example of how this can be asked on the AP exam. Well, more challenging examples. So far we have only considered ideal stoichiometry. You have the exact amount of two things and produce something. But there's another concept called a limiting reactant. Consider a sandwich is made of 2 slices of bread and 1 slice of pineapple. like a lovely sandwich shown here. If you have 8 slices of bread and 180 slices of pineapple, what is the maximum number of sandwiches you can make? We can write a balanced chemical equation. 2 bread plus 1 pineapple yields 1 sandwich. But what's the maximum number of sandwiches you can make? Is this dictated by the maximum amount of reactant, pineapple? No, because I can't use 180 because I only have 8 slices of bread and they come together in very defined ratio. What can I do? I can use the balance equation. I can start with how many sandwiches I can make using the bread, ignoring the pineapple. 8 bread, and it's a 2-to-1 ratio. I can make 4 sandwiches. How about if I just ignore bread and see what's the number of sandwiches I can make with only pineapple? 180 slices of pineapple, and it's a 1-to-1 ratio. I can make 180 sandwiches. Which one limits the amount of sandwiches you can make? Bread. So therefore, we say that bread is my limiting reactant. This dictates the number of bread in this case, in this particular case, dictates the maximum amount of sandwiches you can make, not pineapple. And we call pineapple that is not limiting an excess reagent. I have excess amount of pineapple, unlimited. Let's look at how it works out in chemistry problem. If I have 8 grams of oxygen gas reacting with 9 grams of H2S, what's the theoretical yield of water? So this is a typical limiting reactant problem. I need to do stoichiometry twice. I start with 8 grams of O2, divide by the molar mass, times the mole ratio, times the molar mass of water. I see that for 8 grams of O2, I produce 3 grams of H2O. How about for H2S? I have 9 grams of H2S. I divide by the molar mass, multiply the mole ratio, multiply the molar mass. For 9 grams of H2S, I yield 4.75 grams of H2O. Which one is my limiting reactant here? I see the amount of product, water, is limited by the amount of O2 I have. So therefore, I effectively conclude that O2 is my limiting reactant as it limits the amount of products produced. And this is my theoretical yield. I cannot produce 4.75 because I do not have enough oxygen. Note that there's some common mistakes in this type of problem is that you must choose one product to compare. You cannot do H2O for O2 and then choose to do SO2 for H2S. Then you don't have an even comparison. Now let's look at a small challenge. If 8 grams of O2 react with 9 grams of H2S, same thing. What is the mass of the excess reactant left over? From the previous problem, I know that O2 is my limiting reactant, so H2S must be my excess reactant, or I have too much H2S. So the amount of product can be produced from O2 is 3 grams of water. I should find how much H2S do I exactly need. Let's look at it. So I'm going to, so this is from the last slide. So using 8 grams of O2, I produce 3 grams of H2O. Now I'm going to use 3 grams of H2O to back calculate how much H2S do I ideally need. So I'm going to do this backwards. Given H2O, find H2S. It turns out that I need 5.68 grams of H2S to react with 8 grams of O2. But I have too much H2S. I have 8 grams, but I only need 5.68. So I can subtract 9 grams of H2S minus 5.68 grams of H2S needed, I have 3.32 grams of H2S left over. This is similar to the pineapple problem. How much of pineapple will be left over? Well, I can only make 4 sandwiches, so therefore I can do the total amount of pineapples minus 4. That's how much I'll have left over. In this case, H2S works the same way. This is an example of how to solve a limiting reactant problem. Thank you for watching. See you next time.